Hello everyone and welcome to my 10th video. Also wishing all my viewers a very happy new year 2022. So today's video will be on the Umlun Micro Hydel Project, which for some of my viewers perhaps will be a much awaited video. So thank you for watching and tuning in. So before starting this video, I have divided the video into different timelines. So if you want, you can watch the entire video, or you can skip to different parts of the videos based on different topics as you wish. So let's move on, and I want to give thanks to 3 awesome people for this project, without whom really the project would not have been possible. First and foremost, I want to give thanks to my dear grandfather, Mr. G. Semle, once in a generation visionary, a very genuine, caring person, and he has really helped a lot of people, not only just his family, his employees, but also many people of the society, and many people directly or indirectly have been touched through his works. From the bottom of my heart, I really wish him well for his upcoming years also, and we are all very grateful to him for all that he has done for us, and all the staff and employees also. We wish him well. In behalf of all the employees of Anderson Tea Estate also, we wish him all the best, and we thank him from the bottom of our hearts. Second person that I would like to give thanks is Sir B.K. Bhatt. He is now retired, but at the time of the execution of this project, he was the director of the small hydro program of MNRE, Ministry of New and Renewable Energy, Government of India, based in Delhi, central government. So really, I would really want to give him thanks for the central financial assistance for making this project happen. And he's, I have to say, from my personal experience, a very humble person, and I was very humbled and really touched by the way he does things also. And just to give you a perspective also, the application form which I filled up for the CFA, the Central Financial Assistance, for this project also was just 1 page, and Sir really did not take time in releasing the funds also. He came to the site, visited also, and really I think it sets an example also for other departments also to follow in Sir's footsteps, and the precedent that he has set in executing the projects, which I believe really takes it to the heart of the matter, instead of really unnecessary sideways things, really just to the heart of the matter of the subject. So thank you, sir, and we wish you a very happy retirement life also. Third, I want to give thanks is Kong Lai Plang, Assistant Superintendent of Power Department, Government of Meghalaya, also known as Kongji. So really a very sincere government employee. Is very rare to get such a person, very selfless person who really devotes her time to her work in spite of the many work issues that the government has also. But without her, really this project also would not have been possible. So I really want to give thanks to her also, and thank you for making this project happen. So now I'm standing at the Pondage of the dam, also the reservoir, and you can see the beautiful view of the tea estate here, and the serene ambience that the Pondage has created also. There are many birds which come visit the site. I guess some storks, crane, kingfishers. You can see one bird there also perhaps. So it's really a nice environment here that has been set up. And this is the pondage of the project, as I had mentioned, and the project is 50 kilowatts, 2 turbines each of 25 kilowatts, and when this is completely full, this gives a runtime of 3 days storage time is here. So we have flexibility with the system here also. So if you can see over there, that is the earthenware, that is the earthen dam. And you can see this has created a beautiful setup where people can just come relax also at the same time. So I can take you there to the dam, and then we can show you forward how it looks like. Thank you. Alright, so right now I'm standing at the earthenware or the dam right now, and you can see these stones are here. These are also known as riprap, and behind is just soil only. Actually, we had done a soil test on the soil here, and we got it as silty clay, which is good enough to hold up the water here. And you can see we were standing somewhere out there before, and you can see the length of the pondage, which comes up till here, and from there you can see the intake is over there, and I'll be going there in a while, but just for you to get an idea of the dam out here, and then I'll just insert here a video of the project outlay through Google Earth so that you'll be able to understand. So this is the view of the Umlun Micro Hydel Project as seen through Google Earth Pro. At the start of the video I was standing somewhere over here, and right now I'm standing at the embankment over here. So this is the embankment, the earthen embankment, which is just made out of soil which has been dumped here, and this over here is the intake. So the water comes through like this, through the intake, through the channel, and over here, this area here, the overflow water goes back to the stream, and only the water which is required is taken through this channel here to the desilting tank. In the desilting tank, the sediments, sand, silt, etc. are flushed out, and the clean water is taken through the Headrace channel here like this for a length of around 230 meters up to the Forebay. So from the Forebay, it is just a tank where water is stored for some time before going down to the powerhouse. So from here the Penstock line is buried inside here, and this goes to the powerhouse here where the turbine generator set generates power. After generating power, the water goes back to the stream. So from here the power generated is sent back again through a transmission line like this to the tea factory. So as mentioned, this is the dam or the earthenware of the project, and as you can see, there's nothing special here. This is all just soil only, and soil, as I had mentioned earlier, this we had got some silty clay, as you can see from the hill here also. So grass has nicely grown over it, and this has prevented the erosion of the soil also. And we have planted some trees also. You can see some palm, some trees have naturally come up, and you can see the pondage coming there also, and some stones there, also known as riprap as mentioned earlier, to arrest the erosion. And you can see the length of the embankment. So we had just dumped the soil here, and then compressed the soil in layers to stop leakage. So to a certain extent it has really helped in keeping in check the water here, and the height is also not much, it's just 1.2 meters only. So if you'll come with me, I'll show you the intake and the other structures here in the embankment. Alright, so right now I'm standing at the intake of the dam here, and you can see this is the gate of the dam. So this is made from a local workshop, nothing special here. You can see the shaft, it has been threaded in a lathe machine, and below is the gate there, which has been made from a GI sheet. So this is 45 centimeters, and in front is 90 centimeters. So this is a bell mouth opening and comes down like this. So from here you can see the channel. So the width is 1.5 meters. So why it is big is because we have to accommodate for the flood also sometimes during the heavy rains. So for that, you can see this section here, which is bigger, and during heavy rains water gushes through this section here and onto the channel. So the height is not much, this is just 1.2 meters from the intake level below till the flood level. So you can see here there's this one contraption below, This is actually a lawn mower there, and in the next video perhaps I'll upload on the functioning of that. So right now let's focus on the intake. And if you had watched my first video, that is the Tasku Pico Hydel project, it was a simple valve opening of a, which you just get from market. So this is slightly bigger, but we have made it by ourselves only, and nothing special. So to help me open this one, I'll just call the operator of the project, Mr. Strongwell Lingdo Long Line. If you can kindly come. So you can say hi to the camera. Yeah. So he's been here right from the beginning for around 6 years now, and he's done a very good job also. He's from the local village here only, from Umran Dairy, and we have trained him, and he's operating his work very well also. So let's open the gate. So we have opened the gate right now, and you can see the washer gushing through now. Okay, so I'll take you along the length of the channel and we'll see the different components again. So I'm right now at the end of the channel, and you can see here the water coming from the channel, which is 1.5 meter. So this is actually just the water which happens during the flood season. Okay, so you can see the spillway there, and what we really need is just this. This is it. This is just 45 centimeter, means 1.5 feet only, and that is all that we need for generating 50 kilowatts. So you can see there's a small gate opening here and a channel here. That's it. So since you have seen the difference now, and I just want to clear the misconception also, that a lot of people think that hydro projects are bad, and there's a lot of misconception about this. So here, since you have seen with your own eyes also how much water we actually require, it's very less. So I want to quote Professor Arun Kumar of IIT Roorkee. When I had done my training there, he said that, in a joking way of course, that solar is like the favorite son of the government, and hydro is like the prodigal son. So in a way it's very true also. So here we use the water also only during the monsoon season, when there's leaf to be processed in the factory. So it's a matching cycle, and really hydro and tea, I guess they're made for each other. So I would like to take this opportunity once again to show you about this bridge which has been made from an old chassis. If you had watched my 8 video, if you haven't, you can check it in the link above here. And now we can just open the gate here, and I'll just call Strongwell again once more to help us open the gate, and we'll be moving on to the next components. Alright, I think that will do for demonstration, and this is also again once more made from a local workshop, nothing fancy here, and we'll be going to the next component, which will be the desilting tank. So this is the desilting tank, and you can see the water coming out from there and settling here and then going again. So if you had watched my first video, this is a slightly bigger version of the desilting tank there, but the function and the principle is the same. So the intake level and the outgoing level is the same, and this is in the shape of, some say it's in the shape of a boat, some say jokingly it's in the shape of a coffin, but anyway, this shape helps in the reduction of velocity of water, wherein the sand and soil, whatever particles that may be in the channel, goes like this and then settle down in a projectile sort of motion, and then from there we flush out the desilting tanks once in a while. So this is the basic principle, and then the clean water follows on through the channel up ahead. So I'll show you again once more from there, and from there we'll go to the Forebay. This channel out here is known as the Headrace channel. Headrace because it's on the top before going down to the powerhouse. So let's follow along the Headrace channel to the Forebay. So the Headrace channel ends up here, and you can see the trash rack here in case any leaves might have fallen, but the water is relatively clear. And the water now comes here. This is what is called as the Forebay Tank. It's basically just a tank for storing water before going to the powerhouse. So if you can come inside, I'll show you how it looks like. So you might be wondering why we have put all these fencing and all like that. This is because we want to prevent people from not falling inside, and any leaves or stones, anything which might clog the system. So all this has been properly fenced up, and there's a joke going around also that the Forebay tank looks like a Hell in a Cell cage of the WWE. So you can have a look around. So the valve is out here below, and sometimes when we need repair we can just open this up and go down for any clogging or anything. So here also we have a bell mount opening similar to the intake, and it goes down to the penstock there below, and you can see the powerhouse there with the blue tin roof there. So similarly, like in the first video, here also we have an air vent pipe which removes any air that might be stuck in the penstock before going to the turbines. So the dimension of this Forebay tank is, if I'm not mistaken, 7 meters, 3.5 meters, and the depth I think 3.2 meters deep. So we have a capacity of running for around 10 minutes in case of any emergencies at full load capacity, that is 50 kilowatts for the powerhouse. So it's a pretty safe design, and I'll just show you the spillway now. So I'm at the spillway now of the Forebay, and you can see the water gushing through now, and this will again rejoin back to the stream. So we have used to have a bulb out here so that the operator from the powerhouse, they can see when water is also coming down below. So this is how the spillway works, and I'll just show you the penstock now. So I'm at the base of the Forebay, and this is where the penstock pipe is connected to the Forebay. You can see the valve there and the air vent pipe there. So here you can see these blocks are used for holding the pipe, and you can see some portion of penstock pipe here. So this is a 300 mm pipe, and as we reach before the powerhouse, that bifurcates into 200 mm. So most of the penstock pipe here is buried. There's a reason behind that. Is you all know about the expansion and contraction due to the thermal process. So we have buried the pipe to kind of insulate it through the earth, and that prevents any expansion and contraction that might happen. So you can see the powerhouse below again one more time, and the entire length of the penstock pipe is buried. So you might ask a question here now, what is the head of the project? So this is around 65 meters net head from the Forebay up till the main inlet valve of the powerhouse. So next question you might have again is, how do I do all this surveys? So if you have watched my fourth video, which is on the tips and tricks on surveying, so you can see how I've used the auto level in calculating the head, and also various other levels also. So these are all pretty very simple, nothing fancy, and you can also do it also. So we'll now go to the powerhouse. So I'm at the powerhouse of the project right now, and as mentioned in my previous video, that is the 9th video, these are all made from old disposed bottle caps only, which have been repurposed. So I would like it if you can watch that video also. So let's go inside now and have a look at the powerhouse. So it's quite simple actually, nothing fancy here again. You can see the 2 turbines here and the control room. So before moving on to the machineries, let's have a look at how we had all started it before. So this is what we know as a V notch here. This is in the shape of VV, and this was used for measuring the discharge, and we had used very simple our own stuff actually, very small TMX 20 excavator, perhaps the smallest excavator, loading into a pickup, and you can see some old photos here. This is the intake earlier, and this is the inside of the turbine. This is a Pelton turbine. You can see the double spoon structure there. So we also had some dignitaries, like I had mentioned, Sir BK Bhatt here. So along with my cousin Kemu, and also Madan, retired director of the Meghalaya Renewable Agency. And also here we have Sir Milan Bora and also Sir MS Rao, the former Chief Secretary. So some more components of the powerhouse, maybe you can see the bottle up there. That is also, if you had watched my second video, where we had used disposed bottle as light. So that is actually a Sprite bottle. That's why it gives the green color. And if you can come out here, this is the old TV which was converted to an aquarium from my third video. So now is the off season, so we have actually removed the fishes. So perhaps during season we'll put it back again. So now let's move on to the machineries. So as I had mentioned when I was in the Forebay, that there's a 300 mm pipe which bifurcates into two 200 mm pipes. So the bifurcation, or the Y piece which we say, is just behind, and then it comes one here and another there. And I'll just show you the components of the turbine pipe also. So this is known as the main inlet valve, and this is a butterfly valve. Butterfly valve because it's shaped like this, and then it's like the wing of a butterfly. So it's called a butterfly valve, and this is the counterweight. And you can see the pressure here also. So that corresponds almost to what I had mentioned earlier, the head there. So from here, this comes like this, and this comes to the turbine here. This is known as the nozzle, and this is a spearhead where we can open and close it. You'll understand when we start the machine. So this, you can see, is shaped horizontally, and it's a Pelton turbine, and there's just one jet coming through. So this is a technique called as a single jet Pelton turbine, horizontal turbine. So this is the flywheel. Flywheel means that any fluctuations that might happen, this will correct the motion. And the rated speed of the turbine is 750 rpm, whereas that of the generator, this is the generator, is 1500 rpm. So to increase the speed, we have a gearbox here. 1:2 ratio means 750 into 2 is equal to 1500. So these fans are actually my own making. I'll perhaps upload this in a later video. And to open the butterfly valve, we have the oil pumping unit here, or also known as OPU. So when we pump it, this will open up and water will gush through. So once that is done, then the generator spins also, and inside we have the control room, and we have the ELC, or the electronic load controller, and the load bank, and then it goes to the factory. So I'll just start the machine. I'll ask the operator once more, Mr. Strongwell, to open the pump, and you'll understand if you can open it. So I'll just open one unit only for demonstration. So now what he's doing is that he's opening the valve, and you can see this is opening valve up here with the help of a hydraulic system here. Yeah, so that is open now, and then he'll open the nozzle now. You can hear the washer gushing in. Now, this is the sensor. So this reads the RPM, and you can see the RPM out there. Perhaps we can go inside and have a closer look. So this is the RPM right now of the generator, and once it hits 1500, then we can start the load bank. So it's just opening now. And this is approaching 1500 now. So now this will try to bring back to 1500 as much as possible. And the frequency, you try to bring it as 50 as much as possible. So you can see the functioning now here, and you can see it's trying to bring back to 1500 again. So here, this is known as the load bank, and you can see the wattage here, and if we increase the amount of water flow again, this will also increase again. So inside here we have the control system, the card, and from here we have the heating element below, where all the electricity generated is first kept here before we send it to the factory. So if I on the switch, then the load goes to the factory. So this is basically how the system works, and I want to give thanks to my good friend Mr. Samshir Singh, Samshirji I call him, from Penstock Hydro, from where we had procured the machines, for helping me with all the electrical collections. In fact, he had done all of them by himself, and he's a really good friend. So thank you Samshirji also for the electrical works here. So we'll just go outside and I can show you again. So you can see the water coming from the tailrace there. It's not much, but they are generating some significant power. So you can see the water coming here again, and this is because we have a comparatively good head, around 65 meters. The turbine is rated at 60 meter head, but it has a 10% overcapacity also. So if you come with me again, oh, by the way, this is known as the tailrace, whereas that is the headrace on top. So tailrace because it's at the bottom. So if you come with me again, so we have here the earthing system here, and within the powerhouse itself we have the earth mat, and all this goes into the ground if there are any faults within the system in the powerhouse. And from the load bank you can see the wire coming out, and this goes to the post out there, and that goes on to the factory. So the voltage generated here is 415 volts, and the distance being not so much, is just around 500 meters or so from here to the factory. So we have not used a transformer, it's a direct connection. And to avoid voltage loss again, there are different types of conductors here, and here we have used the rabbit conductor. We have the squirrel, which is slightly smaller, but slightly thicker is the rabbit, which we use here to avoid the losses. So I hope you have understood the functioning of the Umlun Micro Hydel Project, and I've had some visitors here. When they come, they say that the project is similar to Swades. It's a movie featuring Shah Rukh Khan. So if you have watched the movie, you'll kind of correlate with it. You can have your impressions. So thank you for watching my video, but before letting you off, let's have a look at the waterfall. So this is the waterfall you can see behind me. It's very beautiful, and you can have a closer look. So with that, I would like to end my video. Thank you for watching, and we'll see you in the next one. Thank you.